All right, I'm gonna begin a video here, or do a video on binary input and binary output. And the first thing to consider is what's the difference between text and binary, and it's a pretty significant difference. Let's talk about text output, and let's say that we are outputting a number such as any kind of integer, and we are going to output it as text versus output as binary. So when you're taking the value that you store in number, and let's say that we put in the value 5,000, and you save that as text, what actually happens is it goes and it takes the value that's inside of the number, converts it to ASCII, and outputs that to the file. So you would have your 5,000 here when you output as text, and maybe you'd have some other numbers here in a text file. Now the problem with text is, since you are basically taking the value that's stored in the variable and converting it to ASCII and then outputting that as text, the issue is that each one of these characters is a byte. So essentially we are using 1, 2, 3, 4 bytes for this number. Now if I added another 0, now we're using 5 bytes. And then you also consider the text file. If you need to update it, it's not easy to go in and just add a 0 here, and it's rather inefficient. Let's say that this text file was just full of a whole bunch of numbers, and when you just want to update the first one, then that means the whole file has to shift over to the right. And it's also inefficient because it takes what's inside of the text and converts it to ASCII, then outputs that value as 1 byte per character. So 50,000 is something that we can actually store in 4 bytes in a regular integer, but when it does that conversion process of converting to ASCII and outputting it to the file, it has to output it as ASCII code or ASCII characters that are then put into the file 1 byte per character. If we were to consider it versus binary, now an integer is fully capable of holding the number 50,000 in 4 bytes. So essentially, binary is more efficient. And not only that, when you output the value to binary, you will essentially have the ability to update it easily. I'm going to pause for a second. I got my little dog in the background and she's being noisy. Okay, so that kind of gets into the heart of how binary is different, is because when you're outputting a value or a variable as binary, you're actually outputting the whole variable, the full 4 bytes that represents this number. You're not outputting an ASCII code conversion. So that means that you can go into the file and update just those 4 bytes without messing around with any other values that are in the file. So it's also referred to as a random access file. And I'm gonna go ahead and make a chart here and we'll talk about it. Okay, so this is kind of a simple example of how a binary file could look. And there's actually a lot of history to binary files. Back in the days where we had nothing but floppy disks, we didn't have the random access memory that we have today. So essentially all programs would have to use a floppy disk as if it were RAM. And that's where random access files that's their original start, and now as far as outputting and inputting binary or having any kind of significant file system, binary is definitely the way to go. Now there's some issues that you got to kind of consider when you're outputting as binary, and we'll be talking about that as we go. But one thing that you cannot do is with random access file is save strings, because strings by definition do not have a finite set of space. Essentially, a string can go on for or can use up memory for as much memory as you need. So there's no specific size to a string. So when you're doing binary files, you have to use char arrays. You can't use strings. But this is an example of how you might want to set up a binary file. And essentially, you could have your first 4 bytes in the file be your integer. And what's nice about this is you have that full 4 bytes to use to update. So you could go into the file, go into the region or the area of your file that 4 bytes exists, and update that 4 bytes without touching this 8 bytes or these 4 bytes or the 100 bytes that represents maybe a customer object. And that's the idea of binary files. You can come up with your own file type where you actually put specific areas in the file would have specific values. And that's where you get the idea of a file header. So usually what I like to do is essentially have the first bytes in the file be what basically describes the makeup of the file itself. So I'll give you an example of that, because we're going to actually be saving customers to a file, and I'm going to put in a file header for that. But the whole idea here with binary output is the idea are basically that when you're outputting as binary, you're outputting the whole variable. And you can use it in the file just like you use it in the compiler by changing values, updating them without touching anything else in the file. So this is kind of what they did in the old days. Now the problems with binary files and using it like it was RAM, what would end up happening is you would put your floppy disk in and your program would start using memory on the floppy disk, and then all of a sudden the program would seize. And then what would end up happening is it would corrupt your file. And what the solution for that in the industry was, when we had limited RAM, all these third-party utility software companies came out, and all they did was build things to fix files because, they got corrupted often just because the computer would bug out when it had the file open and not close the file properly, or write just like maybe it would write or do an output where it would get to the point where it was outputting the first 4 bytes of this 8-byte double, and then all of a sudden the computer would blink out. So using binary files as if they were RAM caused a lot of problems. But essentially, when you're doing this, you're building your own database. It could be proprietary. You're basically gonna decide how that file is going to be organized so that you can build utilities to work with it. And that's what we're going to be learning about I'm going to first start with output file stream, and then we're going to do input file stream. And I'm going to talk about some of the common mistakes students make when they're working with a file system. One common mistake that a student will make is essentially what they'll do is they will be working within their directory structure, and they won't simply have the view file name extensions selected. That's critical. If you don't have that, you can cause yourself a lot of heartache. So make sure you have this view file name extensions checked. And in fact, if you're any kind of programmer, it's the first thing you do when you come onto a system is check that. All right, so then we're going to go into some code here. And we're going to start with talking about ifstream. Now, fstream is the library that contains the ofstream and ifstream objects. Now, you can look at those ofstream and ifstream objects. Please ignore the wacky commercials that they have in here for what is this, C++ reference. It's actually a really good site to learn, about the C++ library and everything that's, in it. So fstream is kind of the master of everything. And fstream contains ofstream and ifstream, basically output file stream and input file stream. Now you can use ofstream singly to open and write to files. You can use ifstream singly to input files or input data from files, or you can use fstream to do it both at the same time. Now, here's the next mistake that students make. If you are using ifstream or fstream, the file has to already exist. So if you're doing that, the inventory program, binary file inventory program, I think that's 162 actually, but you need to make sure that the file exists. So I usually always start my when I'm building a file to store data, I will first use ofstream to output it. Then I'll test it with ifstream, and then I'll add another function that uses both ofstream and ifstream to edit a position in the file. So we're going to actually build a customer file, and we're going to put a header on it that describes how many customers are in the file. And we're going to do that with ofstream. I'm going to have some Google searches here because it's been about a year since I've done this. So I'm going to get to ofstream. This is where we're going to start. Now what I want is I want to find an example just so I don't have to remember too much. Okay, let's see. I'm going to go find an example and I'm going to pause and we'll be right back. Okay, so this is sort of what we're going to be building. We're going to have a header in our binary file that represents a 4-byte integer, and what it's going to hold is the number of customers we have in the file. And then from there we will have customer 1, then customer 2, customer 3, and so on. And what we'll be able to do is we will be able to go and update these customers at will within the file without changing any other customers in the file. So this is the direction we're headed, and we're going to use ofstream to begin with, and I found a good reference for that right here. So I'm going to take this is writing binary with ofstream in your C++ reference, and I'm going to put this function inside our code, and then we're going to work with it. Now, this is kind of some interesting syntax. When you're outputting things to a file, essentially what you're working with is first opening the file for binary output and with the ofstream object. So essentially you instantiate an ofstream object and you open it up for binary. And what's nice about this is that it will create the file for you. And one thing that I like to do is I like to always write to the file with no directory structure whatsoever. I just put the file name. And what happens is the executable, since you tell it to not go to a directory, the executable will create essentially a file in the only directory it knows exists, which is where your executable is running from. So your program is running from a folder, and then basically it will use that as the default file directory. So what we'll do here is we're going to make a few changes here. We're going to actually put in an integer here, and this is going to be number or count, and we're going to set this as our first output. And this is kind of an interesting syntax, but I don't like to use this kind of syntax. I like to use the old school method, which is just basically cast it to a char star. And you might think it's really funny, but really, actually, this is just a Band-Aid. They put a Band-Aid on this because you're sending the file just straight up bytes. You're not sending it, you know, it's not type specific. So this char star is not actually converting it to a pointer. Basically, you're telling it to output bytes, and so that char star is kind of a misnomer. Don't get confused with that. That's just kind of like the Band-Aid. Essentially, we're saying output this data as just straight up bytes, and go to the address of the data on the stack or the heap, and get that data the size of the data that you're saving. Now, this since we're doing an integer, I'm going to say count here, and then I'm going to say size of int. Okay, now one thing that I like to do is as soon as the file is created, I like to immediately close it. And what we're going to do is we're going to make sure that this worked, and that means that when we go and look at the file, we should see that the file is 4 bytes. And I'm going to run the method write to file here, write file, and I'm going to just give it the name data.dat. And we don't need to put C:\\, whatever. We don't need to do that. We don't need to do that at all, because we're just going to tell it to output where the executable exists. Now, I believe I am thinking C# here. I'm going to fix this error, and I'll be back. Yeah, that was simple. Just make it a string. So this, we're going to go ahead and run this and test it and see if it works properly. So I'm going to go ahead and just run this line or this function. It's going to pop up, and then we're going to go and look at the file that was created and make sure it was 4 bytes. Okay, so we're going to go to the project, and you see here that data.dat was written. Now there's one thing that you want to kind of keep in mind is when you're within the Visual Studio testing area, your working directory is where your H and seekp files are. Otherwise, your working directory would be here. So if I were to run this program from here, it would put data.dat in this file, this folder. And there it is. So when we're working in the project, this is our working directory. All right, let's look at the properties. So I'm going to right click on this. I'm going to see properties here, and we're going to look at size 40.3. Oh, I'm looking at the wrong file. I was getting worried there. Okay, properties, 4 bytes. Perfect, that's correct. All right, now what we're going to do is we're going to create some customers. Now I'm going to use the customers object from the vectors video, and notice here first off that I'm using a char array. I'm not using a string. When you're doing binary, you cannot save strings because they don't have a set limit. So essentially, when you're working on your project or anything, don't use strings for your object that you're saving to file. Now I'm only going to be doing the ID setting and getting the ID, so I didn't put accessors for the first and last name. That you guys could fill out when you get going on your project or as you continue your project. All right, so the next thing I'm going to do is generate some customers. I'm going to generate 10 customers, output them to file, and then I'm going to create a read file and read them in and print them, and then we're going to create a both read and write file. But before we begin, we're going to also use the seek gets and seek puts pointers, file pointers is what I call them, to edit inside the file in some area. So we're going to go ahead and add a loop here that's going to create 10 customers. And we're going to output each customer to the binary file. And then we're going to look at the bytes and make sure that the bytes are appropriate. So that means we need to also have something to see out that we know of where we can look at the size of the customer. So I'm going to open the file for output. I'm going to have a loop that outputs customers, but first I'm going to output my file header, which is going to be how many customers are in the file. Then I'm going to output a temporary generated customer, and that one, you know, I like to actually have all my variables at the top. So we're going to create a temporary customer here that's going to we're going to use just to generate customers and throw them. I'm just going to put the customer on the stack. We don't need anything significant here. So we output the customer count as our file header. Now we output the customer. Oh, that's the wrong spot. Control Z is your friend. The customer, but here's the key. We got to do it for size of customer. Okay. And this has got to be the actual customer itself. So we've got essentially the file header that's going to be how many customers I'm going to save. And let's actually make this a little bit more simpler. Let's just put in 5 of them. And we output the file header, which is the customer, the amount of customers. And then we loop through how many customers we're going to output, and we output that customer. And what we're going to want to do is we're going to want to change the value of the temp each time through the loop to I. So this is going to be the customer's ID. So the first customer will have the ID of 0, second customer they'll have the ID of 1, and so forth. This is just basically to show you how to output a user-defined data type as binary. And it's usually what I do for most of my lectures, is start out with binary input and output at this point with just this simple example. And then what we're going to do after this outputs is we're going to take, and one thing that I would like to look at and see is the size of customer, so that we can look at our file and make sure that yes, we have 5 customers in there plus an extra 4 bytes, which is going to be your count. And that takes us into, you know, we have customer, this 100 bytes is just a guess. It's probably a lot lower, but we'll have our 4 bytes here, size of customer, size of customer, size of customer, size of customer, and on down. Okay, so let's test this and run it. Okay, so it's 104. Not a bad guess. Not a bad guess at all. Okay, so we should have 5. So we have 5 customers in there. Each customer is 104 bytes. So we need to have 104 times 5. Yeah, I'm not going to think too hard here. I'm just going to throw this in the calculator. 104 times 5 customers plus 4 bytes for the header. So we've got this 4 bytes plus the 5 times 104 bytes, which makes it to 524 bytes. So we should look at our file and we should see 524 bytes. So here is our data. Let's go to properties, did it to me again. Make sure that I am actually selecting that guy. 524 bytes. And that's something you want to kind of do as you're working with binaries. Just make sure that you're doing things properly, and things are getting to where you want them to be. Okay. All right. So now what we're going to do is we're going to read that information with ifstream. And remember, ifstream, the file has to exist, and then we're going to print that information. So we no longer need to do a write to file. Now what we're going to do is we're going to do a read from file. So let's go ahead, and this is the wrong web page. Here we go. I think I was using this one. There we go. So let's go ahead and do ifstream example. C++ ifstream binary. Okay, that might give me what I want. Yes, there is. Okay, there's an example of the seekg. So we're going to be actually using seekg and seekputs coming up here when we're using ifstream. So this is, I think we might want, oh, this isn't what we want. This is somebody's cry for help. Yeah, we could probably use some of it. Okay, there we go. Let's just use some of this right here. You know, it's actually, you know what? Once you get, this is kind of the way I do it, is once you get the write in, then I get the read in. So I just literally just take it and copy it, and then change it. So we're gonna go ahead and do this. We're gonna do read file. Okay. We no longer need to set count. We're going to just assign it to 0. We need a customer to read data into, but we are no longer going to be using ofstream. We're going to be using ifstream. And we're going to call it IFS, input file stream. Okay, we don't need this. And now what we need to do is we need to use IFS read. So basically, IFS read is the function we're going to use to get our data in, and we're going to then cast it to an integer. So I got to get an example of the read function here. I'm going to pause and I'll be right back. Okay, we're back. All right, so some key things to note here is when I'm reading the file from using ifstream, what you're going to do is open the file where the file pointer begins at the beginning of the file. And first we're going to read our header in. We're going to read in how many customers do we have. And that's going to tell us how many times we have to read in the size of a customer. So notice here that when we do our read, we do our char star cast to the address of the, or for the address of the variable that we want to put the bytes into. So it's pretty much an inverse of everything that we did up here. And then now that we know from the file how many customers I have in the file, then I'm going to loop through and read in those into a temporary variable that I'm just going to read one into and then print it. And this is where you could like read in and put it into a vector and whatnot. So there's some code that you should study, and that is, you know, basically it's the same diff bank v2 code that I put out there, and it's actually in your modules here. And this is kind of an example of how your project should look, the direction you should have it in. Pay particular attention to accounts list. So that is actually use the dynamic binding and binary input and output. And it's fairly complex when you look at the code. So I will leave that to you to ask questions about. I can also, do a video on just this code and talk about it. But let's continue off where we were at. We have now essentially created the read file. So let's set up a breakpoint and just kind of look at what happens when we're reading data from the file. We start up, the program first does the read file. The file exists, we already wrote data to the file. And now we want to essentially get the header first. So we're going to read from the file and store it into that count variable so that we know how many customers that we need to read in. So I'm going to do a step over, hover over, yep, it's 5. We've got 5 customers in the file. I continue on with my step over. Did I get a customer in? Yes, I did. ID of 0. So at this point, we're good. I'm just going to hit play, and we should see our rollout of customers. Okay, so that's input and output as binary. Now we get to the true reason for binary is the ability to manipulate your file pointers to go into a file and basically edit a specific record in your file. So if we go back to here, we've got customers here. We've got 5 customers here. I'm just going to put in a third one and just pretend that there's 2 more down here. What we're going to want to do is we're going to want to open up the file where the file pointer starts at the beginning. Then we're going to want to seek and put our file pointer ahead to place on just the beginning of the record that we want to change. Then we read in that data, change it, and then overwrite that whole record. So that's going to be done, it's best to be done with ifstream. And that's where you can open a file for reading and writing both. So I'm gonna go ahead and demonstrate that, editing just a record. Now, of course, you would be building this with a menu system, most likely. I'm just showing you, the basic portions of it. So we're gonna call this an edit file. We're gonna create an edit file function. Actually, edit record. Edit record. All right, so now we are no longer going to use ifstream or fstream. We're using fstream. So I'm going to go ahead and call this in out file. So that's going to be our file pointer. So when you're referring to the actual name, this is what I refer to as the file pointer. And it always begins at the very beginning of the file. It's basically a file pointer is, if you haven't heard the term before, a file pointer is essentially when you're writing to a file, it's your pen as you're going across. And every time you do a write, your pen moves ahead. Do another write, your pen moves ahead. That is your file pointer. When you're reading from a file, it starts at the beginning. You read in data, size of size of int, your file pointer goes ahead, and so forth every time you do a read. Now you can actually manipulate the file pointer any way you want by telling it to go to a certain amount of bytes, like go take your pen or your eyeballs reading in records and move here, the file pointer here, read in this record, and then the file pointer gets moved back, and then we overwrite the record. All right, so we're going to make this. Now there's a certain way to open up a file for both input and output. Line 45 needs to be changed a little bit, so I'm going to go do some research and we'll be right back. Okay, so I've got the example here. We've got to actually manipulate the file flags. iOS in, we need iOS out, and then we need iOS binary. So when you're doing it for input and output, you need to have all three of these flags set up. You need to set it up for input, output, and binary. Basically, this is just one variable that you do bit flipping with to denote or tell FStream how to open up the file, and that's why you got to OR it together, because it's just bit flipping with one variable. That's something that we don't want to get into. That's you guys can look into that on your own. Now that I have my file pointer here, what I'm going to want to do is make sure that I change all these guys that I'm using. One habit that I'm into is that as soon as you open the file, you immediately go down and close it, because if you don't, you could corrupt the file, and or essentially you may, the very worst condition is rebuild the file, of course, and sometimes you have to reboot. So one thing that is going to change is that we no longer need to read. We can read and count. That's a good thing. But what we want to do is we want to ask the user for a record to edit. And what I'm going to do here is I'm going to know how many items are in the file. So my file pointer is going to start at the beginning. And once I do this read, my file pointer, once I read in the count, my file pointer will be right here. So then I'll ask for a record, and then what I'll do is I'll do a seek, a seek gets. Seek puts is for seek puts. Seekp is for when you're doing write operations. Seekg is for when you're doing read operations. So seek gets and seek puts. So we'll go back to here. I'm going to ask the user cout enter record to change. Then we'll do a cn. Let's do an integer for record. And I'm going to assume I'm not going to do any debug or any error handling. That's something you guys can do. I'm just kind of giving you an example. Record record number. We'll default that to 0. So then when the user inputs the record number, let's do a cn record number. rnum. Okay. Now we are going to use this temporary customer is going to hold the one that we want to edit. So we're going to read it into here first, but first I've got to tell the file pointer to move to the desired record I want. Now remember, my file pointer is right here because I've already read it in the count, so my file pointer is now right here. So what I can do is I can just do a seek puts or a seek gets, actually, because we're not doing any kind of input or output, or, well, let's just do a seek, and for that we're going to manipulate the file pointer based on the record number. I'm going to do a little research and poke around a bit and be right back. Okay, so now I'm going to start manipulating the file pointer, and usually what I like to do is I like to just do just move the file pointer to the beginning of the file whenever I do any kind of operation where I'm editing a record. So I'm going to use our file pointer and put out file, and then I'm going to do a seek gets, because what I first want to do is I want to read the record that I'm going to edit into temp. So I have it, and then I'm going to change temp, and then I'm going to do a seek puts and overwrite that record with my edit to this customer that I've read into. Okay, so now what I need to do is I need to do a seekg in out file dot seekg. Now we've got 4 bytes. We need to add 4 bytes. Add 4 bytes for header, and then multiply size of customer by record number, by rnum. Okay, so it's going to be 4 plus size of customer times our number. Okay, now I'm wondering if this will work, and I think if we're doing this correctly, we could probably get rid of this line actually, because we're going to tell it to go from the beginning. So we're going to say iOS beginning. Okay, so we add the 4 bytes to move the file pointer. We start the file pointer at the beginning, add 4 bytes, then take the size of customer and multiply that by our number. So if our size of customer is 104, so our size of customer is 104, and let's say that we put in record number 2. So that's going to be 104 times 2 plus 4. So what we're doing is we're taking, and let's minimize this a bit. We're taking the file pointer and we're telling it to start at the beginning, move 4 bytes, and then move size of customer times 2, which is 208 bytes. So we tell it to move all the way down to here. And then we're going to read this in, and we're going to do seek puts. We're going to edit what we read in. Then we're going to do a seek puts, move the output, the file pointer for putting data. There's actually 2 file pointers. You got your seek gets file pointer, and you got your seek puts file pointer. One's for input, one's for output. So that's why I kind of start out at the beginning with just doing a read and a write, because you're only dealing with 1 file pointer. But when you're dealing with both, you're now dealing with 2 file pointers, one for reading and one for writing. So once I do a seekg of 4 plus size of customer times record number 2, that's going to be an ID of, the first one's 0, then the second one is 1. So we might have a fence post there, but I'm thinking we should get an output of customer ID of 1. So let's do this. Let's do our read. Let's do our read that we build up here. That's another reason why I kind of start out this way, is because it's kind of organized. You know, you start with outputting to the file, reading from the file, then editing a record in the file with ifstream. And by the time you get to the hardest part of everything, which is ifstream, you've already got pretty much all the syntax you need. So let's see how this works out. We're going to read with our input, our in-out file. We're going to read in the temp, and then what I want to do is I want to do a cout temp.getID. And we're going to actually do this in the debugger. When you get to this level of working with stuff, you want to actually see it happening in front of your eyes. It's much easier to work with. Okay. Set a breakpoint right here and just make sure that everything's kind of working right. We should get a 5 here for count. Oh, I forgot something. Of course. We need to do this where we edit record. So I'm going to do this. Okay, now let's try this out. Okay, let's see, make sure we get a count of 5 here. Got our count of 5. We're going to enter our record to change, and we're going to go back here and we're going to type in 2. Okay. Now we're going to do a seekg. Now this is where something could go wrong. See if this works. Okay. And this is really where something can go wrong. Let's see if that works. Oh, let's see. Oh my goodness, it worked. ID of 2. Okay, so that is a fence post. There is a fence post there because, as we know, the first record is actually 0, and the second record is an ID of 1. First record is an ID of 0. Second record is ID of 1. But this is actually working properly. We output this other than that fence post, we'll probably have to do this. We'll do rnum minus minus after this, so that we don't have that fence post. So let's actually do this rnum minus 1. Because if we want the second record, it should be outputting an ID of 1, not 2. We got that fence post issue there. Okay, so this should work properly now. Let's go in and let's do this. We're going to read the file, print the file, then we're going to edit a record and print the record, but we haven't really edited it yet. We're just testing right now, make sure that we're getting reproducible results. And okay, now so the first record has an ID of 0, second record has an ID of 1. So when I put 2 here, it should be outputting 1 now. There we go. Okay, so that's working right. Let's try record 3. Okay, that's working correctly. I'll put a 2. Okay, so now what we want is we want to now allow a user to edit this. And let's just do some diagnostics here. Let's do a rnum and a space, record number, rnum, let's see, customer ID of okay, and then we'll do an inline here. Okay, then we're going to do this. We're going to ask the user, we're going to say enter new ID. Okay, and then this is where we're going to change the value of what's inside a temp. So what we'll do is we're just going to read in I think we can just reuse rnum, I guess. I don't, we don't really need to use it anymore after this. And then what we'll do here is we will set temp. We'll say temp dot set ID of rnum. That's going to bug me. We're going to do this. Just stay organized. Okay, so we're going to cn ID. And then we're going to set the new record's ID. Okay, now, so we've read in the record from the proper location in the file. We've edited the record. Now what we want to do is we want to take our seek puts and we want to move it to the record that we read in and then overwrite it. Okay, so what we do now is we can use this very same code here, but it's going to be with seek puts. So now what we're going to do is we're going to go to seek puts. Seek puts, it's going to be seekp, and we're going to go the same amount from the beginning, and then we're going to overwrite the record, and we already have the code for that. It's going to be up here, right there. Okay, we read in the data. We've changed and edited the data. We've overwritten now the data that's been changed. Oh, Control Z is your friend. Okay. Okay, input in out file. All right. So we read the file, print it, edit a record. Then we're going to read the file again and make sure that it changed the record. Okay, let's see if it works. Cross those fingers. Let's see if we're able to use ifstream appropriately. Seek gets and seek puts. And save this, run it. Okay, I'm not gonna do any debugging. Okay, enter record to change. Let's change the fourth one, the number 3. Okay, let's make that 99. 9999. Okay, so that number 3 should change into, oh my goodness, we got it. We're good. All right, so now this is gonna be somewhat how you will build your project, or how you should have done input and output for your project. But I have a more significant example for how your project should look and how you should have done loading and saving using a vector. So that is right here. It's in your vectors. No, actually, I should be putting that in your vectors area. That's actually, that should be down here, because it actually uses vectors. So I'll probably be sending out an email to tell you guys to study that. I'm going to put this video in Chapter 4 assignments. I think that's it. That's pretty much the lowdown on input, output, and editing a record using binary, or basically the whole idea of binary. It's really kind of a cool way of doing things. You're basically building your own database, and start with the way I start out. It's good habits. There's a lot of when you've done this so many times, your habits are ingrained. Your good working habits are ingrained, and you saw how I started and I worked my way through. By the time I was done, and I got to the hardest part, I was literally just copying and pasting code. Thank you. Goodbye.